All right, guys, this is the 2014 BC exam number 5. Okay, this question right here, you have a graph over here, and the graph is trapped by 3 pieces. You're trapped by a curve, a slanted line, and a vertical line. And in part A, it wants you to find the area of the shaded region. So if you look over here, you kind of can tell you have 2 trapped regions, sort of. If you break it up, you have a triangle, okay? And then you have the area between the blue graph and the x-axis. So the area of my triangle is 1/2 times, well, my base length right there is 1, and my height is 2. So that's where those guys are coming from. And then when you integrate the curve between 0 and 1, you're integrating an e. So I want you to think about integrating e to the u. E to the u integrates to e to the u. In my u spot right now is an x squared. The derivative of x squared is 2x. So to do my shortcut method, I just put a 2 in front of the x, and the balance is a 1/2, and those guys cross off. So you're left with 1/2, and then in a box, e to the x squared evaluated at 1 and 0, and then you guys know what to do from there. Okay? Part B, you're taking this shaded region and you're rotating it around the line y equals -2. So this is the disc and washer method. And this guy right here, what you do is you find the volume of the outside curve being rotated, and then you want to subtract away the inside curve being rotated. So it's like, I'm going to make the solid, I'm going to figure out what that whole distance right there is, and then in a minute, I'll subtract away the white part, okay? So the distance that blue line is that I just drew, well, the distance between here and the x-axis is the curve. Like, that's what the curve stands for. And then you have an additional 2 units. So there's my first radius right there. That's the curve plus 2 units squared. Now, the hard part is subtracting away the white part right there. And you got to kind of think about it weird. We want to get rid of the distance that blue line right there is representing, okay? And so the distance between here and here is 2, all right? So that's what that's about. And then I want to get rid of the distance between the x-axis and the slanted line right there, right? So that distance right there, well, that's like 2x. I know the graph is y equals -2x, but you could think of the distance right there as just 2x. So what I've got right here, well, that's representing, again, the distance between the x-axis and the axis of rotation, and I'm subtracting away, that's representing the distance from the x-axis to the maroon graph, okay? And then in part C, you're asked to find the perimeter of the shaded region, which again consists of a curve plus a vertical line plus a slanted line. Okay, you need to use your formula sheet to look at how you find the arc length, because this is an arc and you're looking for its length. So the integration of 1 plus the derivative squared, and then right here I just wrote out for you how I found my derivative, okay? Plus the vertical line, well, I split the vertical line up into 2 pieces. The distance between here and here, okay? That's just like plugging a 1 into the blue graph, which gives me 1 times e to the first. So that's where the e is coming from. And then the distance between here and here, well, that's just plugging a 1 into the maroon graph, so that's -2. Well, the distance is 2, so that's why that's a +2. And then the distance of the slanted line right there, well, the slanted line makes a right triangle, okay? And you know that this distance is 2, and you know that distance is 1, so the Pythagorean theorem will help you find the distance of that slanted line, which is the hypotenuse of a right triangle. Okay.